In this line of code, we are importing necessary modules and dependencies from FastAPI, such as FastAPI, file, upload file, and HTTP exception. These will enable us to handle file uploads in our application using FastAPI framework. In this block of code, we are importing the open function from AFiles and renaming it as async open. This function is used to asynchronously open a file in the save upload file function. This is helpful in handling input-output operations asynchronously, which improves the performance of the application. In this line of code, we are importing the path class from the pathlib standard library. This class will help us handle file paths and manipulations, making it easier to save the uploaded file in the desired location. In this line of code, we're creating an instance of the FastAPI class, calling it app. This is the starting point for our FastAPI application, which allows us to define routes, handle HTTP requests, and set up middleware. Confidence, 95%. In this block of code, we're defining an asynchronous function called saveUploadFile that accepts a file object file. Upload file is an argument and returns a string. This function is responsible for saving the uploaded file to the server's file system. It opens a file with the same name as the uploaded file in write binary mode asynchronously using async open, reads the file content in chunks, and writes the chunks to the buffer. Once the file is fully written, it returns the file name. This asynchronous function helps in efficiently handling input-output operations, improving the performance of the application. In this line of code, we're defining an asynchronous function called saveUploadFile that takes a file object file, upload file as an argument, and returns a string. This function is responsible for saving the uploaded file to the server's file system. By using the async keyword, this function can perform input-output operations asynchronously, which helps improve the performance of the application. In this block of code, we're using the asynchronous context manager to handle the file IO operations. The async with statement is used to asynchronously open the file with the name of the uploaded file in write binary mode using the async open function. We then read the file content in chunks of 1 to 24 bytes and write those chunks to the buffer as long as there is data to read. This approach efficiently handles large files and allows for concurrent file handling. Confidence, 95%. In this line of code, we're returning the file name of the uploaded file after successfully saving it to the server's file system. This allows the application to provide feedback on the uploaded file's name, or use it later in the application to access the saved file. In this block of code, we define a FastAPI endpoint for handling file uploads. The @app_post_upload_file decorator tells FastAPI to create a new post request endpoint at the upload file route. The upload file coroutine function will be executed when a client sends a post request to that route. Inside the function, it receives an uploaded file using the file upload file parameter, saves the uploaded file using the save upload file coroutine, and then returns a JSON response containing the saved file's name. If an exception occurs during the file saving process, a 500 internal server error HTTP exception is raised. In this line of code, we define a FastAPI endpoint for handling file uploads. The @app_post_upload_file decorator tells FastAPI to create a new post request endpoint at the upload file route. The upload file coroutine function will be executed when a client sends a post request to that route. In this line of code, we define an asynchronous function called uploadFile that handles file uploads. The function takes a file object file, upload file as an argument with a default value of file. This function is responsible for processing the uploaded file, saving it using the save upload file function, and then returning a JSON response containing the saved file's name. By using the async keyword, this function can perform input-output operations asynchronously, which helps improve the performance of the application. In this block of code, we're handling the uploaded file within the upload file coroutine function. We first try to save the uploaded file using the save upload file asynchronous function, and if successful, we return a JSON response containing the saved file's name. If any exception occurs during the file saving process, we raise an HTTP exception with a 500 internal server error status code and provide a detailed error message.